Oya site is located in the Uva region to meet agricultural demands. Oya project will transfer the turn of the river from Oya and Mahatitola River to Alikota. The project's elevation is 1000 MSL or mean sea level at the upstream and 200 MSL at the downstream. The pertinent part of the project includes the two-roller compacted concrete gravity dams, Polpola at Oya River. A 4-kilometer conveyance tunnel transfers water from the first dam to the second one. And Dairaba Dam at Mahatitola River. The headrace tunnel with a length of 15.5 kilometers will transfer water from Dairaba Dam to the powerhouse. At the end of the headrace tunnel, there is a surge system. A concrete pressure shaft by diameter of 3.2 meters will provide the required waterhead to produce energy. The underground powerhouse consists of 2 caverns with a capacity of 120 megawatts and is situated at the end of a 2-kilometer access tunnel. Another tunnel named Tail Race will transfer water to the project's downstream. At first, and before starting execution of operations in main parts of the project, workshops and the site's equipping activities were initiated that included construction of access roads, resident camps and offices in a 14,000 square meter land, and after that in 2011, when the employer handed over the land, warehouses and workshops were constructed. Polpola Dam, as the first dam, is situated on Oya River, with a height of 35 meters and 2 bottom outlets, which is an RCC-type dam that holds 635,000 cubic meters of water in the reservoir. The second dam, which is a bigger dam in dimension, is Dairaba Dam that is located on the Mahatitola River. The height of this dam is about 50 meters with 3 bottom outlets. The concreting of Dairaba dam body finished in June 2017. These 2 dams are connected to each other via a tunnel with 3.9 kilometers of length in order to transfer reserved water in Polpola Dam to Dairaba and then to the powerhouse and downstream area. The excavation of the conveyance tunnel got over in January 2017 with the minimum and least deviation. A tunnel is planned to transfer the water from Dairaba Dam to the powerhouse with 15.2 kilometers of length, which is called the Headrace Tunnel, that is being excavated with TBM. It has to be mentioned that TBM is being used for the first time in Sri Lanka in this project. TBM does the excavation with automated mechanism and segments are installed inside the tunnel for steel lining by the machine itself, and in the end, the excavated material is taken out by the locomotive. In the initial method statement of HRT excavation, the operation was supposed to be carried out only through tunnel outlet, but due to the geological conditions and also for giving speed to the operation despite all obstacles caused by the negative slope of the tunnel, another TBM started to excavate from the intake of the tunnel in the middle of 2016. Water passes 15.2 kilometers, and before flowing into the powerhouse, its pressure and velocity should be decreased. That is why a vertical shaft is planned with 680 meters of height, in which the water enters and goes to the powerhouse passing the valve chamber. Raise boring machine was used to excavate shafts. The machine excavates in two phases. At first, it works from upward to downward by excavating a 30 centimeter diameter hole, and after finishing pilot, it excavates vice versa towards the upside, a shaft of 3.2 meters in diameter. Also, this machine was used for the first time in Sri Lanka, and the operation itself, with now an intermediate tunnel, is unique in the world. The operation of shaft excavation finished in February 2017. After completing excavations, pressure shaft wall is covered by metal sheets called steel lining in order to resist against water pressure flowing in the shaft. Water reaches the powerhouse after passing the pressure shaft. The powerhouse was excavated with a 2-kilometer sloping tunnel by explosion and excavation method 750 meters deep in the ground and it includes various access tunnels for different parts of the powerhouse. The excavation of the powerhouse and transformer caverns finished in January 2016. And immediately after that, constructions and concreting stages in different floors started and finished by January 2017. The main equipment needed for the powerhouse has been purchased from leading and well-recognized Western and European companies. The major parts of turbines and generators in both units have been installed, and the remaining work is in the process of being installed. The powerhouse supplies 120 megawatts of electricity, which are done by two separate 60 megawatt units. The electricity produced in the powerhouse passes transformer, MAT and escape shaft towards the switchyard. Then it's sent to Badula substation through a 22-kilometer transmission line to reach the Sri Lanka National Electricity Circuit. Finally, water gets out of the powerhouse towards the downstream to be used in agriculture and water supply for those areas through the tail race tunnel. This tunnel also was excavated with TBM and automated machines, and it was completed in January 2015 after 9 months of excavation.
විදුලිය නිෂ්පාදනයෙන් පසු එම ජලය යොදා ගනිමින් ප්‍රධාන වශයෙන් අලිකොට ආර ජලාශයත් හඳපානාකල ජලාශයත් කුඩාඔය ජලාශයත් එහා බැඳුණු 100කට අධික වාරි පද්ධතියකුත් පෝෂණය කිරීමට සැලසුම් කොට තිබේ. අලිකොට ආර ජලාශය තුළ අකරාටි 5200ක ජලධාරිතාවයක් ගබඩා කෙරෙන අතර එහි සිට කිලෝමීටර් 35ක් දිග ප්‍රධාන ඇල ඉදි කරනු ලැබේ. පවතින ඉඩම් අක්කර 1600කට සහ නව ඉඩම් අක්කර 1500කට වාරි ජලය සැපයීමට මෙම ජලාශය මගින් සැලසුම් කොට ඇති අතර වැව් 40ක් පෝෂණය කිරීමටද නියමිත වෙයි. වැල්ලවාය ප්‍රාදේශීය ලේකම් කොට්ටාශයේ ඉපැරණි හඳපානාගල වැවේ ජලධාරිතාවය අක්කරාඩි 15000ක් දක්වා වැඩි කරවමින් හඳපානාගල ජලාශය නිර්මාණය කොට තිබේ. පවතින ඉඩම් අක්කර 3200කට හා නව ඉඩම් අක්කර 4000කට වාරි ජලය සැපයීමට මෙම හඳපානාගල ජලාශය තුළින් සැලසුම් කොට ඇති අතර කිලෝමීටර 11ක් දිග ප්‍රධාන ඇල මාර්ගයක් ඉදිකිරීමට හා දැනට පවතින වැව් 20කට අධික ප්‍රමාණයකට වාරි ජලය සැපයීමටද නියමිත වෙයි. සැබවින්ම උමාඔය බහුකාර්ය සංවර්ධන ව්‍යාපෘතිය නිසි මාර්ගයට රැගෙන එහි උපරිම ඵල ප්‍රයෝජන ඌවේ ජනතාවට ලබා දීමට අනවරතව ක්‍රියා කරනු ලැබුවේ